Hey, my name is Omar, and I'll be talking about EnergyVis, a tool for interactively tracking and exploring energy consumption for machine learning models. Before I describe EnergyVis, here are some statistics from related work that highlight energy consumption for near state-of-the-art NLP models, while comparing them to activities in our day-to-day lives. Training these models sometimes requires substantial amounts of energy, resulting in significant CO2 output. Motivated by these statistics, EnergyVis aims to interactively track energy consumption and carbon output. Other reasons for tracking energy consumption involve replication concerns. As models grow larger and larger, computational resources might make replication for these models prohibitive. Furthermore, energy from training these models can be repurposed towards powering homes or other essential infrastructure. Finally, because parameter counts for machine learning models are increasing faster than Moore's law, tracking energy consumption will become increasingly important. Concretely, EnergyVis offers the following contributions. First, EnergyVis allows practitioners to interactively explore energy efficiency costs, like carbon output or kilowatt hours consumed. Second, EnergyVis allows practitioners to compare efficiency projections from other models, overlaying their model with alternatives. Finally, EnergyVis allows users to explore alternatives for reducing energy consumption and carbon footprints using hardware or location alternatives. The EnergyVis UI consists of 5 coordinated views. The Energy Profile view allows users to load EnergyVis with pre-trained models, in this case a vanilla transformer or BERT, or live track their own model. The Consumption Graph view allows users to overlay selected alternatives, including alternative energy profiles, onto their original consumption. The Energy Intensity Map component allows users to explore alternative regions with cleaner energy sources. The Alternative Hardware component allows users to explore alternative hardware configurations. And finally, the Color Equation component allows users to interactively explore how their emissions and energy are being calculated. Let's jump into a quick demo, starting with the Energy Profile view at the top. I can choose to import my own energy profile, or I can select one of the predefined ones in the top bar. In this case, I just want to go ahead and select a transformer model that someone has already live tracked for me. Cool. Now I can also change, right now carbon output is reflected, but I can also change this output to the raw electricity usage. Also, I can hover over different states and select another alternative state that I want to train my model in. Clicking on this state fixes the state. EnergyVis will prompt me with an entering what if mode. If I click yes, the state will remain fixed. Now, why don't we try to explore alternative hardware configurations? Let's say I'm in the market for a new GPU, specifically an RTX 2080 Ti. I can go ahead and add this GPU, choose to explore alternatives, and reduce the quantity of my old GPUs. In this case, I can see that the RTX 2080 Ti is more energy efficient, resulting in a decreased level in the alternative consumption. Now, if I'm ever confused for how my CO2 emissions are calculated, I can head down to my color equation components and view how these metrics are computed. Color equations are color-coded, so the variables align with the text descriptions. Color equations can also be dynamically edited in some instances. For example, let's say I know the value of a coefficient that adjusts for electricity used by other resources, the PUE coefficient. I can directly edit it inside the user interface, and my consumption graphs will change appropriately. Finally, if I want to ever live track my own model, I can enter a live tracking mode and enter a live energy profile URL, and the model will listen to EnergyVis's backend API and automatically update the consumption graph. If you want to learn more about EnergyVis, feel free to visit the following link or scan the QR code. Thank you for listening, and we hope you enjoyed our presentation.